Cybernetics Made Easy, Part 2, The Governor, by Robert Johansen. The term cybernetics was taken from the Greek word for governor, because the cybernetic control system that was first studied by scientists was the governor on a steam engine. This is a diagram of the governor on a steam engine. We will go through it one part at a time. First, you see the picture of the boiler, the steam valve, which directs steam to the steam engine, which drives a drive shaft, which drives the load. If we look at the governor, we can see the four cybernetic processes happening. Act. At the bottom of the diagram, there is the boiler. The boiler produces steam. Above the boiler is the steam valve. The movement of the valve controls the amount of steam which goes to the engine. The steam engine translates the steam into work. The work is the turning of the drive shaft which moves the load. Since the valve controls the amount of steam going to the engine, it also controls the speed of the drive shaft. Some interpretations stress the provision of collateral energy by the boiler. And then there is the schematic. At the bottom you see the action, which is a change in the steam valve position, which gives more steam to the steam engine, and the steam engine translates that into drive speed. Sense. This diagram shows the gear that connects the drive shaft to the spindle. The gear system translates the spinning of the drive shaft into the spinning of the spindle. This is called the feedback takeoff. When the load varies, the speed of the drive shaft varies. Some analysts call the variation in the load a disruption and see the cybernetic process as a response to disruption. It's important to note that the energy that goes to the governor is significantly less than the energy that carries the load. This is considered of immense importance by some interpretations. So we see below the diagram, we see the schematic. Changes in the drive speed are translated by the gear into the perceptions, or the speed of the spindle. Evaluate. The spinning of the spindle is translated into centrifugal force by the fly balls. The fly balls are connected to a sleeve, and the centrifugal force of the revolving fly balls translates the spin into the vertical motion of the sleeve. The movement of the sleeve is an evaluation, or a need. The upward motion indicates that the engine is going faster, while a downward motion indicates that the engine is going slower. So below the picture of the fly balls and the sleeve, we see the schematic. So perceptions, namely the speed of the spindle, is translated by the fly balls into needs, the vertical change in the sleeve, faster or slower. Choose. Here you see a picture of the lever. If you look at the left side of the diagram, you will see that connecting the sleeve, there is a lever that goes all the way from the sleeve to the steam valve. The lever translates the vertical motion of the sleeve into a change in the steam valve. When the sleeve goes up, indicating an increase in speed, it closes the steam valve and slows the drive shaft. When the sleeve goes down, indicating a decrease in speed, it opens the steam valve and increases the speed of the drive shaft. As a result, the drive shaft maintains a constant speed. Below the diagram we see the schematic. On the right-hand side you have the needs, the change in sleeve, faster or slower, which are translated by the lever into a change in the steam valve position. So that we can do a schematic of the process like this. A change in the steam valve position is translated by the steam engine into changes in drive speed. The gear translates the changes in drive speed into perceptions, or the speed of the spindle. And the fly balls then translate the speed of the spindle into a change in the sleeve, faster or slower. And the lever then translates that evaluation into a change in the steam valve position. Some of the terms seem odd when applied to a machine. Calling the speed of the spindle a perception seems anthropomorphic, but the meaning is dependent on the system. The speed of the spindle is information about the speed of the engine. It is information in a form that the governor can process. It is thus the governor's perception of the engine's speed. To describe the position of the sleeve as a need or an evaluation seems strange. Once again, the meaning is dependent on the system. The governor has a homeostatic goal. It seeks to keep the engine moving at a constant speed. Thus, in relation to the system's goal, the position of the sleeve expresses the need for the engine to speed up or slow down. Referring to the lever as options seems odd until you realize that there are actually two different ways you can connect the lever. It can be connected in a positive way so that an increase in speed of the drive leads to an increase in steam, or in a negative way where an increase in speed leads to a decrease in steam, and vice versa.